All right, everyone. I'm your host, James Drummond with Codenvy. Thank you for attending CheConf 2016. In this session, our presenter, Patrick Chanezon with Docker, and our very own founder and CEO, Tyler Jewell, will share with you their presentation on Docker 101 and Docker in Che. Patrick is currently at the airport. So hopefully the audio comes in clear. We have him on his cell phone. Go ahead, Patrick.
All right. So can you all see my screen?
Yes, we can.
Okay, very good. So hi everybody, and sorry for the TSA announcement. You can hear in the background. I just landed at JFK I'm on my way to the Microsoft Connect conference. So today, this talk is about Docker 101, kind of trying to give you an idea of all the stuff happening in Docker and how to get started using it. And then Tyler will talk to you about how Docker powers Eclipse Che. So a little bit about myself. I spent 10 years in my career building platforms at Netscape, AOL, and Sun, and then 10 years evangelizing them at Google, VMware, and Microsoft. And I joined Docker a year and a half ago. Why was Docker successful? I'd like to start with that. Why are we here today? So this is my take on it. There's a very important transformation that's been happening in the enterprise world in the past 5 years, where enterprises who were pretty reluctant to go to public clouds now have started moving to it. And so the way I see the market looks something like that, where you have private cloud on the left, public cloud on the right. Most enterprises want a hybrid strategy. And I will talk to you about the various players in there using a movie analogy. So to me, VMware on the left, most enterprises are using VMware, and a lot of the workloads are virtualized today. And so VMware, to me, they're like the movie 300. It's the story of 300 Spartans who resist an army of 10,000 Persians. They're very courageous. They shout Sparta, but at the end, they all die. So to me, that's kind of where VMware is today. They're trying to survive a little bit longer with the alliance they set up with Amazon recently, but it's kind of a difficult situation. On the other hand, on the right, you have Amazon, who created the public cloud market. To me, they're pretty much like Independence Day 2. It's a very bad movie, but there's a very fun scene where an alien spaceship lands on Earth, and there's an American general who calls the president and who says they landed in the Atlantic, and the president says, where? And he says, everywhere, because the spaceship is as big as the Atlantic. And that's pretty much the effect that Amazon made on the enterprise market when they landed with their massive public cloud. To me, Google is pretty much like Back to the Future. In that movie, there's a young kid from the 80s who goes back to in time to the 50s. He gets on stage, he starts playing rock and roll, and the people love it because they're ready for the rock and roll music. But then at the end, he starts getting too excited and he plays hard rock, and that's music from the future, and so there's a big silence, an easy silence. People are not ready for that music from the future. And to me, that's pretty much the Google Cloud Platform, where there are lots of very interesting technical aspects to it, but very often they don't provide the path from where people are today to where they want to be in 10 years. Microsoft, to me, is like Terminator 2. In Terminator 1, it's like the Microsoft of Steve Ballmer, where Linux is like cancer and open source is horrible. Terminator 2 is the Terminator from... it's the Microsoft from Satya Nadella, who's an ex-Sun guy, don't forget that, and he's coming back and he's the good guy this time, so they want Linux and Java and all kind of workloads in Microsoft. And Docker, to me, was successful because it appeared 3 years ago at a time when enterprises wanted to start creating these hybrid clouds, using private and public cloud, and having a uniform uniform layer to insulate them from the various cloud providers. And Docker provides that. It provides the portability that enterprises want when they move to a multi-cloud and hybrid cloud world. So to me, Docker is like Charlie at the chocolate factory. We produce chocolate and everybody loves them. There's some kind of magic in there. So what does the stack look like in that new world? So at the bottom, instead of hardware, you have either your virtualization provider or your cloud provider, so VMware, Azure, Amazon, GCP. Then you have the operating system on top, and the operating systems shrunk a lot in the past 3 years. CoreOS started that trend with a very small distribution of Linux with just the kernel, a few utilities, and a Docker engine. And the distribution is just designed to run workloads in containers. Very quickly, the whole industry followed. So Red Hat has Atomic, Ubuntu has Ubuntu Core, RuntimeOS is another one, Photon, Alpine that I should add to this slide is the one that we're using in Docker different editions. And then even Microsoft shrunk Windows Server. So Windows Server 2016 has a version called Nano Server that has no UI and that's just designed to run Docker workloads in Docker engine. On top of that, you have Docker. On the left, you have a whole ecosystem of plugins for things like volume or networking. And then on the right, you have orchestration, which has been where there's been a lot of innovation in the past 3 years. The top orchestrator is Docker Swarm. There's Kubernetes by Google, which is pretty popular as well, and Apache Mesos. So at Docker, what we build is tools of mass innovation. That's our mission statement. We build tools of mass innovation, which means we take technologies that exist, or we invent new ones, and we build tools that allow a lot of people to innovate. What's really interesting, an area where there's potential for a lot of innovation right now is programming the internet. What we've seen in the past 5 years is a lot more devices are getting connected to the internet, from cars to sensors to drones, and all these need to be programmed. And right now, the programming tools for building programs for these are siloed. And what ideally you want to do is to create programs that are distributed, that span several of these devices. So that's what we're building, a platform to program the internet. And that platform is in the form of a stack. So it's built on standards at the bottom. So standards are things like OCI, the Open Container Initiative, an initiative Docker started with 20 different companies, 40 different companies in the industry. Everybody's in there, and we're standardizing the container runtime in there and image format. On top of that, you have infrastructure. So these are plumbing components, things like runc or containerd, components that Docker is made of, but that you can use independently. Then on top of that, we have an opinionated platform, and that's the Docker platform that I've been talking about. And then on top of that, we have commercial products. So Docker is based on Linux kernel isolation features that are called namespaces and secrets. So namespaces let you create processes in Linux that think they are alone on the machine and have their own file system and network system. And C groups allow you to control how much resources these processes get. So it's operating system level virtualization. Just to comment, Windows also gets the same primitive, the same kind of isolation primitive in Windows Server 2016. So since a month and a half ago, with the help of Microsoft, we created a new backend for Docker based on Windows Server 2016. You can create Windows containers on Windows Server as well. So Docker works both on Linux and Windows. Another very important aspect of Docker that really drove its adoption is that notion of union file system. So when you create images, Docker images to package all your software, these images are based on layers. And these layers are sit on top of each other. They are coupled together with a union file system, and on top of it, you have a copy and write file system for the container when you create it. The result of that is that if you have 15 different applications that all use Ubuntu, your Ubuntu base image will be downloaded only once, and then the cache will be reduced. So when you're a developer and you want to Dockerize an application or to create a new application and use Docker to develop it, you write what is called a Dockerfile. The Dockerfile specifies everything that's in your image. Very often you don't start from scratch. So there's an image that's called Scratch. That's when you want to create something out of nothing. Very often you start from a base image. For Java developers, for example, you're going to start from the Java image. So here I do from Java 8. That means I want to start from the Java 8 image. And in there will be a Java 8 GRE. Then I specify who the maintainer is. I expose the port, so that's the expose directives. So I have a series of directives I use there. Then I'm going to copy a jar from my machine in the current context where I have compiled it inside of the container here in /user source spring-doge.jar. Along this talk, I'm going to take as an example this application called Spring Doge that Josh Long built. It's a Spring Boot application using MongoDB. So it's a simple web service application with a UI, REST API, and then MongoDB as the backend. Then I set the working directory, and then in order to start my container, the command directive just says I'm going to do a Java -jar of the jar I just copied inside of the container, and then I specify a few parameters like server port. I open it on 8080, and here you can see I pass an environment variable that I'm going to set when I run that container that has the URI to reach MongoDB. And the health check directive is a pretty new one. It's in Docker 1.12 since this summer, and that's really useful. That lets you, the application developer, specify a command that Docker Engine is going to use to verify that your container is healthy. So here I specify that every 5 minutes I'm going to run that command. I'm going to wait for 3 seconds, and I'm going to retry 3 times. If after 3 times it fails, if the command returns with an error code, Docker is going to consider that my container is not healthy. And in the context of a swarm cluster, for example, where I have like maybe 50 instances of that service, Docker will be able to reschedule some new ones if the ones I have scheduled are not healthy. And so here the command, I'm just curling local host on port 8080, and if my application answers, it means it's healthy. So then after that, one of the very nice aspects of Docker is that you can use it at many different levels. And we've seen people in enterprise and in startups using Docker for very different things. You can adopt it gradually. So you can start by using Docker just to compile your application. So here, for example, I don't want to install Docker on my machine, so I'm going to use Docker. I just don't want to use to install Maven on my machine. So I'm going to use the Maven container here to compile my code. So the way I do that is I do a Docker run -it to create the terminal, -rm to destroy the container when it's done. I'm going to mount the current directory, so $pwd. Inside of the Maven container. That's a trick. That's a nifty trick when you're using Maven to compile Java code. You need to create a volume called Maven to host your Maven cache. That's the best practice. So here I mount that Maven volume into /root/.m2. So all my Maven cache will be reused across different compilations. And then I'm going to write the result out into that directory, and then I run Maven package in there. So that will compile my code. Once I've done that, I can build an image. So here I'm doing a Docker build. -t lets me assign a tag or a name to that image. So here I'm going to call it Chanezon /springdoge dot, which is the current context. So when I do that, it's going to take the jar file that I just had created and create a container out of it. Once I've done that, I can analyze my images, looking at Docker history, and then to run a container, it's a Docker run. I can pass some parameters, like, for example, the environment variable where Mongo is running. So here, MongoDB URI, I expect it to run on a host called Mongo. I open port 8080, but I map the outside port 8090 from my local machine inside of the 8080 port of the container, so I can map lots of different ports, and I run my container with that. So that will just start my application. Now, one of the things that bothersome here is that I will need to set up Mongo on my Mac and launch it and have a script, shell script to launch all that. Why don't I use Docker to launch Mongo as well? When you start to have lots of different services in your application and you want to start all of them together, you can describe your application in what is called a Docker Compose file. So Docker Compose is a tool of the Docker toolkit that allows you to specify a multi-container application with a simple YAML file that looks something like that. So here I have a web service with the image Chanezon Spring Doge, my ports mapping. Here you can see the link. I start a Mongo image, and so MongoDB is going to be in that container service. And then the environment is MongoDB URI is Mongo. And since the second service is called Mongo and I put a link in there, the two are going to be linked by an overlay network. There's a new ServiceAPI in Docker 1.12. So that's an alternative way of creating your services. So you do Docker network create to create an overlay network. Then you create the Mongo service, and then you create the Spring Doge service. So I'm just going to show you how all that stuff works. So I'm just going in the terminal here. I'm in Spring Doge. I'm going to start by like using a Maven container here to compile my code. It's scanning my project. While it's running, I'm just going to show you the structure of the project. So here I'm in that Spring Doge directory. I have a Dockerfile dev. That's the file I showed you. In there, I have the Spring Doge project with all my source, and it's going to create the result, a jar in target. Jar there, springdoge.jar. So the Maven step is still working because I just recompiled it before coming here. Once it will be finished, I'll be able to create my image and then run my service. And I can run it with a Docker Compose file. Oops. So here I'm done with compiling it. Then I can build my image. So it's sending all the build context with a jar file inside of a Docker Engine. Docker Engine builds my image. And then I can run all my service with Docker Compose. Docker Compose -f. Oops. Sorry. Docker Compose I think it's called run, and I do Docker Compose up, and it's going to start my Spring Doge images. So it's creating a container. For that, it's creating the Mongo container, the web container, and it's streaming all the logs to me. And once all that was done, I can go on localhost on my browser. Localhost on port 8090, and my application will show up there. In parentheses, I wanted to show you Docker for Mac. So this is Docker for Mac running. It's a version really optimized for the Mac, where I can see everything in there. I can set some preferences. I can change the memory and the CPU, and it just works. I just don't need to set up anything. So let's see if the GI has started. Okay, so my application is serving from there, and I can. So there are lots of tutorials that show you how to debug from there and all that. But since we have a short time, I'm just going to go quickly through the rest. There are lots of tutorials on GitHub Docker Labs for Java developers to get started with Docker when you're doing Java. What's been new in Docker in the past few months? First, on the developer side, so we think the best tools get out of the way, adapt to you, and make the powerful simple. So what we released is Docker for Mac and Docker for Windows. That's what I just showed you. In terms of orchestration, The best way to orchestrate Docker since Docker 1.12, since last summer, is with Docker itself. We built orchestration inside of Docker itself. So there's a new mode called Swarm mode in Docker 1.12. There's a ServiceAPI I told you about. It's very secure. There's cryptographic node identity and all the load balancing. There's a built-in routing mesh that does load balancing for you. So it's very easy to set up. To set it up, if you have it on your Mac, you do a Docker Swarm in it, and you're good to go. Start using that. The other aspect is the ops experience. So lots of ops want to deploy Docker on different cloud platforms. We released Docker for Amazon and Docker for Azure for that. I'll skip that. The last aspect that's super important, last month, Docker for Windows, Docker for Windows Server shipped with Windows Server 2016. So now with Docker, you can create .NET applications and Java applications, .NET applications running on Windows and Java applications on Linux. Have them work together. The last aspect is the Docker Store. So Docker Store is in beta, and as of today, Docker or Codenvy worked to put Eclipse Che inside of Docker Store beta. So you can run Che from Docker Store. You just need to install Docker, and Che will just run. Same thing for Codenvy. And Docker today joined the Eclipse Foundation. We're going to publish a blog about that in an hour. The last thing, we're doing a commercial product as well, where the goal is agility, portability, and control. And these products are called Universal Control Plane and Docker Trusted Registry, and they are for enterprises who want to put Docker in production, either on-premise or in the cloud. And so they are secure, they're connected to Active Directory and LDAP, and there's a rich permission model going with it. Docker Data Center 2.0 or GCP 2.0 shipped yesterday. So it's a good time to take a look at all the new stuff that's in there if you're an enterprise and you want to start using Docker. I think I used up all my time. I think now Tyler is going to tell you about how Che is working with Docker and why Che is using Docker, Che and Codenvy.
Okay. All right. Thank you, Patrick. That was the fastest introduction to Docker that I've ever seen before. That was really entertaining. I think we'll look to get some of the capabilities around the audio cleaned up and potentially some subtitles a little bit later. But why Docker and why so important to Che? And I just wanted to walk through the things that we do with Docker and how it allows us to deliver Che to you. The interesting thing is I tell my investors all the time is that Docker provides really two very special qualities that are fundamental game changers. The first is that a container, which has its own miniaturized runtime in there, has a boot time measured in milliseconds. And when something that is measured in milliseconds around boot time, it means that you can create new instances of applications or servers or anything running in a container with virtually no overhead associated with it. And that instantaneous access really changes the game in terms of how you approach system architecture and system design, because you no longer need to depend upon services running 24/7, and instead you can create lots of instances of the environment, or if they were to fall apart, you could restart them. And that's certainly one component of it. The other component is that the descriptive nature of the container is done in a Dockerfile. And by having it being descriptive, that makes it prescriptive. And when it becomes prescriptive in that way, we can suddenly now have control over what goes on inside of the container runtime, and then give that back to the end user, which is the developer here. And so those two basic capabilities open up a whole new toolbox of capabilities that we haven't had access to before. Now, the first thing that we do is we use Docker to actually run your workspaces. So these are your workspace runtimes, and they can be Dockerfiles and compose files, and that's absolutely fantastic. But we also use Docker for building your workspace, so that if you provide us a Docker file, but you do not give us the image, we can dynamically build that for you and then cache that. And we will cache that either on disk or whatnot. When you have multiple containers that are part of a single compose file, we'll do a Docker network so that those containers can discover one another and communicate with each other. We have the compose file capability. We're able to package up the Che server as a Docker container and put it onto the Docker store. So that gives us universal operating system access to the Che server so that it can run on Windows or Mac or Linux. We have a concept called the Che launcher, which simplifies how you start and stop and run and configure the actual Che server itself. So it provides configuration management, and that's provided as a Docker container. And then all of our utilities that we give to end users, such as mount, action, and SSH, these are also packaged as Docker containers that have their own independent release process. And we can even go so far as to using very simple things like if we need to do an IP address lookup on the host, or if the host doesn't have curl installed on it, which is oftentimes doesn't happen on Windows, why do that? We can actually just use a Docker container for that. We can download a 4 megabyte Docker container, run a curl command, and then toss it away. So Docker allows us to rethink our developer tools. It allows us to rethink the utilities that we create to help our end users start and stop Che, and also the utilities for interacting with Che. So this very basic innovation allows us to open up and do a lot of things for developers that just haven't been able to be done before. And I was just very thankful that Patrick could come on today and share a little bit about what makes Docker special with Che, and how to get started working with that here. And with that, I'll hand it back over to James, and we can start thinking about the next session today.
All right. Well, thank you very much, Tyler. And thank you, Patrick. I know it's a little bit busy there at the airport, and we'll try our best to clean up the recording. Thank you to all the viewers. I know it was a little rough on the audio, but it is really special anytime we get a presenter from Docker. It is a key component of Che and our success. So, so without any further ado, this concludes the presentation of Docker 101 and Docker and Che. Josh will be hosting Extending Che with Jonas from Eclipse Source, Kalene with Zend, and our very own Stephen, whose birthday is actually today as well. So happy birthday. He's with Codenvy.